In this video, I want to have a look at calculating arc lengths when we're measuring things in radians. So we already know from our video on radians that theta, so the size of the angle defined in radians, is equal to the arc length L divided by the radius of the circle. So we can rearrange this to find the arc length. So we'd multiply both sides by r and we'd end up with the arc length is equal to the radius times the when it's measured in radians. So just to clarify that with the diagram, here we've got our circle, we've got the centre of our circle here, our circle has a radius of r, and we've got this angle theta in the middle. Our arc length is from the point B to A. So that's the length of our minor arc, and to find that, we would have this bit, which is on your formula sheet. So we'd have the arc length is equal to the radius times that angle in radians. Now, sometimes it might ask you for the major arc length. And if we did that, we've already got this angle in here, and we'd have to use that to find this angle out here. And then we could use this same formula. All right, so let's have a look at an example. So our first question asks us to find the length of an arc formed if an angle of pi over 4 is subtended at the centre of a circle with radius 6. So you don't have to draw a diagram, but if we were, just so we can visualise it, we've got our circle here. We've got an angle of pi over 4. Now pi is 180, so pi over 4 would be equivalent to 45 degrees. So just so we can get an idea of how big it is. So that's our angle in there of pi over 4. It's extended with radius 6. So that's our 6 along there. And we're finding the distance from this point to this point along here. So that arc length there. So our arc length, using the formula on our formula sheet, would be our radius of 6 times our angle measured in radians. So that would be pi over 4. So for us, it would be 6 pi over 4, but we'd simplify that down to 3 pi on 2, and that is centimetres. So that's the exact value. We could then put it in our calculator if it wanted us to find an approximation or to round it off to a certain number of decimal places. Our second example is a little bit different. So it says, what is the radius of a circle in which an arc length of 12 centimetres subtends an angle of 150 degrees at the centre? And it wants us to answer correct to 2 decimal places this time. So we're still going to use this formula, but it's going to be a little bit different. So we know our length is equal to the radius times that angle, but this angle needs to be in radians, and at the moment we have 150 degrees. So we know that pi is equal to 180 degrees, which would mean that 1 degree would be pi over 180. So then to figure out what 150 degrees is, to convert that to radians, we would have 150, not 50, times pi over 180. And that would give us 5 pi on 6 when we simplify it down. So this is our angle, our theta in this problem. We also have the arc length this time, so our 12 is equal to the radius times 5 pi over 6. So now we need to rearrange this to get our r on its own. So let's multiply both sides by 6. So we'd have 72 equals r times 5 pi. And then we can divide by 5 pi. So we'd have r equals 72 over 5 pi. But it asks us to correct to 2 decimal places. So we're going to put that in our calculator and round it off. And we'll end up with 4.58 centimetres. And that's to 2 decimal places. All right, so that's an introduction to finding the arc length.